Welcome to this video tutorial on debugging Android applications. Today, we'll explore essential debugging techniques and tools that can help you identify and resolve issues in your Android apps effectively. Before we jump into debugging, let's talk about why debugging is important. As developers, debugging is a critical skill because it enables us to identify bugs, understand how our code runs in real time, and improve the stability and performance of our applications. In this tutorial, we'll cover several topics, including using the Android Studio Debugger, Logcat for logging, breakpoints, and the Android Profiler for performance tuning. Let's start with setting up our debugging environment in Android Studio. Ensure that you have a project open and ready to go. First, let's take a look at the Logcat console. Logcat is a command line tool that helps you view logs from your device or emulator. You can access it in Android Studio at the bottom. To make the most of Logcat, you can filter certain log types. For example, to view only error logs, you can select error from the drop-down menu. This technique is very useful when you're trying to isolate issues. Now, let's add logging to our application. Use the log class provided by Android. Here's a sample implementation in our main activity class. We'll use different log levels such as log.d for debugging, log.i for information, log.w for warnings, and log.e for errors. Now that we have some logging set up, let's talk about breakpoints. Breakpoints allow you to pause the execution of your app so you can inspect the code, variables, and flow more closely. To set a breakpoint, navigate to the line number in your code where you want to pause execution. Click in the gutter area next to the line number, and a red dot will appear, indicating a breakpoint has been set. With the breakpoint set, let's run the application in debug mode. To do this, you can click the debug icon or press Shift plus F9. The application will install on the emulator or device, and execution will pause at our breakpoint. Once the app hits the breakpoint, you'll see a debug window at the bottom of Android Studio showing the current state of the app. From this window, you can see the call stack, inspect variables, and step through the code. You can use the step over F8, step in F7, and step out Shift plus F8 features to navigate through your code. Additionally, you can evaluate expressions by selecting a line of code and using Evaluate Expression from the debug options. Another helpful tool within the debugger is the Watches panel, which allows you to monitor specific variables. Let's add a variable to the watches to see how it changes over time. We can also modify the variables on the fly from the debugger. This technique can be useful for testing how changes might affect behavior without needing to rerun the entire application. Next, let's focus on performance debugging using the Android Profiler. The Android Profiler helps you analyze your app's CPU, memory, and network usage. You can access the Android Profiler from the bottom toolbar in Android Studio. Click on the Profiler tab to view a graphical representation of the app's runtime performance. Keep your app running on the device. As the application runs, the Profiler will collect real-time data that you can analyze. This tool is useful for detecting memory leaks, excessive CPU usage, or slow network requests. When you want to analyze memory usage, you can click the Memory Profiler. This section allows you to take heap dumps, which can help identify memory leaks or unnecessary memory consumption. To detect memory leaks, look at the instances of objects within your heap dumps. Check for objects that should have been garbage collected but are still alive. Utilize tools like Leakanary for a more detailed analysis. Now, let's address some common pitfalls and techniques when debugging Android applications. One common issue is understanding the life cycle of Android components. Make sure you're aware of when to initialize data and resources based on activity or fragment states. Another essential practice is to test your app on various devices and Android versions. Use Android Virtual Devices, AVDs, with different configurations to ensure compatibility and catch device-specific issues. Additionally, always read the stack traces provided in Logcat carefully. They provide a wealth of information regarding exceptions and context about where the issue originated from. In case you encounter a crash, you'll often see an exception thrown in Logcat along with a stack trace. That stack trace indicates the chain of method calls that led to the error. Here's how you might encounter and log an exception. One of the best practices is to use version control systems, VCS, effectively when debugging. If you introduce a bug and need to track down when it was introduced, VCS like Git can help you stash changes, compare versions, and revert back easily. As we conclude, remember that debugging is an iterative process. You may need to repeat various debugging techniques multiple times before identifying the root cause of a bug. Thank you for joining me in this detailed tutorial on debugging Android applications. I hope you found these tips and techniques helpful in honing your debugging skills. If you have any questions or comments, please leave them in the section below. Don't forget to like, subscribe, and hit the notification bell for more Android programming tutorials.